Hi class. Today we're going to start chapter 10, and the concept in chapter 10 is still hypothesis testing, only now instead of having one sample, we're going to have two samples, and we will compare either two sample means or two sample proportions. So section 10.1 is comparing two means with unknown standard deviations. So we're going to have the sample means, and then we're going to do a hypothesis test to make some sort of conclusion about what's going on with our population. First off, we're going to be working with independent samples in this section. And what that means is that the values from one population are not related to or paired or matched with values from the other. So you have your group here and you have your group here, and we're not connecting these at all. They're distinct, and how we choose those from this sample and how we choose those from this sample, it's not going to impact our results or our decisions. In dependent samples, the sample values are going to be connected. So you might have one sample here and one sample here, and maybe you study somebody before they received a medication, and then you study them after they received a medication. So those would be dependent samples in that you would need to compare that person to themselves. You can also have pairs that are connected by another means. Like maybe you're doing a study on marital satisfaction, and so you would study the husband and the wife, and you want to compare those two to each other. You wouldn't want to compare one husband to somebody else's wife. Siblings would be another connection. You know, maybe you're looking at some sort of study and you're comparing siblings and their heights or their IQs or something like that. You would want to connect someone to their own sibling. So in this section, you're going to have independent samples. In section 10.4, we're going to learn something called matched pairs. And the dependent sample part will make a little more sense then, because you will have pairs that need to be matched up. In this section, you are going to be doing a two-sample t-test. So just like when we were talking about one mean, we did a one-sample t-test or just a t-test. Now we're going to have two samples that we're comparing to each other. So it's going to be a two-sample t-test. There's going to be something in the calculator that asks whether the sample is pooled or not. And we're going to always say no. I do want to explain what it means by pooled, though. So looking here, if you're looking at what is pooled, when you're looking at building your study and pulling data for a sample, you're going to have two different samples, like we said. And if you can assume that the two population standard deviations are the same, then you would say yes to pooled. So it's almost the idea that these two samples are pretty much coming from the same population. And you would be assuming that the population standard deviation from one sample is the same as the population standard deviation of the other sample. The majority of the time, number one, we don't know the population standard deviation, so we can't assume that it's equal. And the likelihood of the population standard deviation being the same is very low. So none of the ones that we're going to do are going to have the standard deviations equal. So we're always going to say no to pooled. And again, that's making the assumption that the two population standard deviations are different. So I would look at it as you're pulling this sample from one population, you're pulling this sample from another population. And it's safer if you're going to make an assumption to assume that they're not equal. Again, pooled, you're going to say no. And I'll show you when we enter in the calculator how that works. Okay, so we're going to look at our examples. I think you're going to find, for the most part, these are just an extension of what we were doing before. When you look at the examples, you're going to see we're still finding our null and alternative hypothesis statements. We're still finding a test statistic and a p-value, and we're still writing a conclusion. And all of the rules that we learned about that process, about that step 1, step 2, step 3, step 4 process for hypothesis testing remain the same. The only difference now is we're comparing two samples, so we're going to have a different test that we use or a different calculator function. And yes, there's a formula we could use as well. The calculator will do the number crunching a little more easily. So you can think of it this way. You're choosing either a formula to substitute into, or you're choosing a calculator function. So we're going to be choosing a calculator function. Let's read this study, and then I'm going to give you some suggestions for getting started, some things that help. This one says, many studies have been conducted to test the effects of marijuana use on mental abilities. In one such study, groups of light and heavy users of marijuana in college were tested for memory recall with the results given. Use a 0.01 significance level to test the claim. So here's our claim. Test the claim that the population of heavy marijuana users has a lower mean than the light users. And then it has a question here as well. Should marijuana use be of concern to college students? You could probably answer that question right now. Okay, I think you could see where it's going. This is a college textbook. I think we can see what they're going to be leading us toward as far as a conclusion. We do know our level of significance. We already know how to talk about that. Alpha is 0.01. And this is talking about heavy marijuana users have a lower mean. So see, it has that word mean in there. So we basically have two groups. What's kind of nice is that they've organized it here for us. This I'm going to call group 1. This I'm going to call group 2. So the light marijuana users I'm using as group 1, and the heavy marijuana users I'm using as group 2. You can compare them in whatever order you want. If you wanted to label it the other way around, that's fine. Typically in the book or on the MyOpenMath, they're going to order them in the order you see them. But if I had called, the light marijuana users 2 and the heavy marijuana users 1, that would have been okay. We're comparing means. So we're going to have the mean from the first group and the mean from the second group. And the same thing down here. The claim says that the heavy marijuana users have a lower mean. They scored lower on this memory recall test. Okay. Our heavy marijuana users are number 2. So right here, these are the heavy marijuana users, and these are the light marijuana users. We're saying that the mean score on that test is lower for the heavy marijuana users. This is our claim. This one will be our equal. And again, we're checking. Is this score on the test significantly lower for the heavy marijuana users? Or you could read it the other way around. Is the score for the light marijuana users significantly higher? You'll see here I put light and heavy. I noticed on the MyOpen Math, sometimes they'll go like this. Instead of putting 1 and 2, they might put like L and H for light users and heavy users. Or there's one, I think it has like east and west, so they put an E and a W. So it's just a way to keep track of which is your first sample and which is your second sample. The other thing that sometimes kind of helps people, and I'll just show you down here, is we're looking at this vertically. Sometimes if students write it this way, like light users, heavy users, and then you decide this is sample 1, this is sample 2, whichever way you decide. And then you could keep track. N is 64, the mean is 53.3, and the standard deviation is 3.6. You could keep track this way. And then based on our claim, it said the heavy marijuana users have a lower mean. So we know this score on the test over here should be lower than the light users. Okay? So the thing that usually gets students is if they're not careful in keeping the 2 samples organized so that they know which one is sample 1 and which one is sample 2. Be cautious with that. And also be extra careful when you're choosing this symbol in your alternative hypothesis, because the way that symbol is facing is going to depend on which one you call number 1 and which one you call number 2. Okay, so we're going to do, we have 2 means. So we're going to do a 2 sample t-test. And what's nice about that, we've already done for 1 mean, we do a t-test. For 2 means, we have 2 sample t-test. And I'm going to pause this for a sec so we can move over to the calculator and I can show you how to enter it. Again, the key thing is really just keeping the information organized so you know what's sample 1 and what's sample 2. So you can see here, I went ahead and wrote down what we had already completed on the problem. And then I put the statistics that we were given in the problem over here so that if you don't have the sheet right in front of you, you can reference it and I can reference it. Okay, so we're going to do our 2 sample t-test. We're going to go to stat, over to test, excuse me. And then we're going to go down to where it says a 2 samp t-test. And what's nice about using the calculator, it's going to prompt you what to enter. So our first option, do we have data or do we have statistics? Well, we were not given a list of data. We will in another example. But this first example has statistics. And then you'll notice we have to enter a bunch of information. This is the mean from sample 1, the standard deviation from sample 1, and the sample size from sample 1. Mean from sample 2, standard deviation from sample 2, and sample size. So this is all our information from 1. This is all our information from 2. You can go through and put the 1 in there and the 2 in there if you want. I don't typically do that. Just be careful that you're entering the right information because you're going to enter 6 different values. Okay, so the mean is 53.3 and the standard deviation is 3.6 and the sample size is 64. The mean over here is 51.3. Sample standard deviation is 4.5. And the sample size is 65. Our symbol here is a greater than symbol. Oops. There we go, lock it in. And then remember we talked about pooled, we're always going to say no. And now we calculate. And we end up again with a test statistic, which is t equals 2.79. And our p-value is 0.0031. Now, what's nice, you already know how to write conclusions. You already know how to make a decision about reject or fail to reject. This is the only new part. Well, and I guess writing your hypothesis or hypotheses statements, they look a little bit different because they don't have a number. They have two symbols. So here, let me change colors. This is less than alpha. Alpha here was 0.01, so it's small, which means we're going to reject HO. And this tells us that we are supporting our claim. Supports the claim. And you could put it word for word. There is sufficient evidence to support the claim. Supports the claim that, and we're going to say heavy marijuana users have a lower mean than light users. I'm just going to put heavy users score lower than light users. Okay. There's also a question here. Should marijuana use be of concern to college students? Well, what do you think? Yes. Should be of concern. And then maybe I'd put here impacts memory recall. Okay. As long as we're on this problem, I want to talk a little bit about your project. If this was something someone was doing for their project, one of the things that I would want in the introduction, we're talking about these light and heavy marijuana users. Something that always bothers me about this problem, I want to know, well, what makes someone, what's the definition of a light marijuana user? And what's the definition of a heavy marijuana user? And how did you find that out? You know, are we going to have an honesty factor, honesty in response? So some of those things you would address in the introduction before you did your analysis. And obviously this would be probably a little challenging to do for your project. I did have a group that for their project wanted to give people a math test before they drank alcohol, had them drink, and then give them a math test and see if it made a difference with how they did in the test. So they did something kind of similar. They checked with me first and we made sure everybody was 21 or older and all that. What made it extra challenging is the people in the study did really poorly on the math test to begin with. So they really couldn't do much worse. So they really weren't able to support their conclusion that drinking the alcohol, they would do worse because they did so badly to begin with. So it was kind of entertaining. And it was definitely one of the more creative subjects or topics that I've had people use for their project throughout the many years of teaching statistics. It stands out in my mind, that project. Okay. So we've talked about how to enter in the calculator. And my main suggestion, again, is to just be really careful with what are your two samples? What is the order you're comparing them in? And being really careful with the statistics or the data that you don't get it mixed up. When you look at it in paragraph form, it's easy to get it mixed up. So you might try, writing something like this to help you keep that information organized. And pooled, always say no. Okay, let's go back and look at the next problem. I'm just going to pause this for a sec. Okay, so we're back, and I just updated the notes sheet with the information that we found with the calculator. So you can update yours as well. And we're going to look at the next example. And when I choose my examples, I try to make sure that I give you at least one of each type. And you can see here that we have a list of data. This example says that below are student evaluation scores of female professors and male professors. And then it says, test the claim that the female professors and the male professors have the same mean evaluation ratings. And then it asks the question, does there appear to be a difference? Okay. So you can see that you have data here. You can also see in the claim that they're talking about a mean. So if I'm going to think of my two groups, I'm comparing the females to the males. And again, it doesn't matter which order you write it in, but typically we write it in the order that it appears in the problem. And I think you'll find when you do My Open Math, it does it that way as well. It wouldn't be wrong if you did it the other way, but the consistency, it probably will make it easier if you stick with going in the same order. So our females are going to be our group 1 and our males are going to be group 2. And we're talking about their mean evaluation ratings. So the mean from the first group, the mean from the second group. And it says they have the same mean. So the claim is up here. Well, if that's an equals, that means the alternative hypothesis is a not equal. So when we go to do this, we can see we have two means. So we're going to do a 2 sample t-test. And this time we have data. So we want to enter in list 1 our female data and list 2 our male data. And I am going to go grab the calculator so that you can see how we would do this. So right now, entering list 1 is going to be the data for the female instructors, and list 2 is the male instructors. You can see I took the time to enter the data. Hopefully you did as well. That would save us, or save you having to watch me do it. So we have the female instructor data in list 1 and the male instructor data in list 2. In this example, they happen to have the same number in the sample, but it's not required. So if you have one sample that's bigger than the other sample, that's okay. It just coincidentally happened to be the same for this one. Because they're independent samples, the sample size does not need to be the same. So we're going to do our 2 sample t-tests. We're going to go to stat. We're going to go over to tests, and we're going to do our 2 sample t-test. And this time we have lists of data. So we're going to go over to data. This asks, where did you put the first list of data? And sometimes this seems kind of strange, but maybe you put your list in list 3, or maybe you put in list 5. So your first, the data that pertains to the first sample, where did you put it? I put mine in list 1. The data that pertains to the second sample, where'd you put that? Frequencies are always going to be 1. And the reason for that, we don't have any data values that we have in a frequency distribution or anything like that. So here, 1 every time. And then we want a not equal. Pooled is no. And then calculate. And we can see our test statistic is t equals -0.32. And you could go out more places if you want. And our p-value is 0.7576, which is pretty large for a p-value. it is greater than any alpha we would have. In this problem, they didn't give us alpha, so we would use 0.05. And it's definitely larger, so we're going to have a fail to reject HO. We're not rejecting it. Okay, by default, we're saying that those mean evaluation scores are the same. Okay, our conclusion: does the original claim have an equals? Yes. Fail to reject, so we would say does not warrant rejection of claim that mean evaluations are the same. Are the same. And then there's a question. Does there appear to be a difference? No, we just found that there was not enough to say there was a difference. So we would say does not appear to be a difference. Okay. So we did one example with statistics. We did one example with data. And again, just be careful when you enter it. There's a little bit to enter. Maybe a little less with the data, but just make sure you're referencing the correct list. So you can see I updated things here. And I just wanted to also highlight it. It says, does there appear to be a difference? So we're saying there's not a difference, but we're really saying there's not a significant difference. I would accept there's not a difference. That's fine. But it doesn't mean they're exactly the same. It just means it's not significant enough to say they're different.